Hello students, welcome to our YouTube channel Experience Tutor. Today we'll discuss class 11th physics, system of particles and rotational motion, chapter 7 ncert solution, part 9. Please subscribe, like and share our YouTube channel. Please click on the subscribe button to support us and also click on the bell icon to get automatic notification whenever a new video is uploaded by us so that you will not miss anything. Let us start today's tutorial. Today we'll start with 7.26. A. Prove the theorem of perpendicular axis. B. Prove the theorem of parallel axis. Let us see the solution. So, question number 7.26. So, part A. Theorem of perpendicular axis. Of perpendicular axis. So let us see the statement first. The theorem of perpendicular axis of perpendicular axis states that the moment of inertia of a planar body, moment of inertia of a planar body, you can also write lamina, about an axis about an axis perpendicular to its plane. In shortcut we write perpendicular to its plane plane is equal to the sum of to the sum of is equal to the sum of its moment of inertia its moment of inertia about two perpendicular axes about two perpendicular axes concurrent with perpendicular axis axis and lying in the plane of the body. So let us repeat the theorem. The theorem of a perpendicular axis states that the moment of inertia of a planar body or lamina about an axis perpendicular to its plane is equal to the sum of moment of inertia about the two perpendicular axes concurrent with perpendicular axis and lying in the plane of the body. So let us explain it with the help of a figure. So in the given image, we have a physical body with center O, a physical body with center O and a point mass M in the xy plane at x comma y. Now moment of inertia about x-axis. So moment of inertia about x-axis x-axis Ix is equal to mx square. Again, moment of inertia about y-axis. Y is equal to m y square. So moment of inertia about z-axis about z-axis will be equal to Iz, which is equal to m under root x square plus y square whole square. Now iz also we can write ix. So this is a equation 1. Now ix plus iy we can write as m x square plus m y square. So now you have to understand the figure here. So moment of inertia about x-axis is mx square, moment of inertia about y-axis is my square, and moment of inertia z-axis is m multiplied by under root x square plus this value is under root x square plus y square whole square. So this is equation 1. Ix plus iy is equal to mx square plus my square. We can take common m as common and we can write m x square plus mx square plus y square. Instead of this we can write m, instead of x square plus y square we can write bracket x square plus y square under root and square. So we have not done anything, under root and square. Why we have done this? To solve the sum, that's it. So xy plus ix plus iy, ix plus iy is equal to m under root x square plus y square whole square. So ix plus iy is equal to m. This whole thing we can write as iz. So instead of this write iz, and this is proved. Now let us see the B part, theorem of parallel axis. So theorem of parallel axis. So first we'll write the statement. The statement is the theorem of parallel axis states that that the moment of inertia of a body about any axis. Axis is equal to the sum of the moment of inertia inertia of the body about a parallel axis. About a parallel axis passing through the center passing through the center of mass passing through its center of mass. Its center of mass and the product of its mass and the square and the square of the distance between the two parallel axes. Between the two parallel axes. Now let us go through the theorem again and try to understand. The theorem of parallel axes states that the moment of inertia of a body about any axis is equal to the sum of the moment of inertia of the body about the parallel axis passing through its center of mass and the product of its mass and the square of the distance between the two parallel axes. So let us prove it. Let us first draw the diagram. So this is the body and here are the parallel axes Q and R. The distance between them is say A. This is PQ one axis and RS the other axis. Both are parallel. So say this is the center of mass, for example M1, and this is the radius R1 R1 about a point O. Now let us prove the theorem accordingly. Suppose a rigid body is made up of is made up of n particles having masses m1, m2, m3 dot 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 mn at perpendicular distance. Distance r1, r2, r3 dot 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 rn respectively. From the center of mass O, of the rigid body, now the moment of inertia the moment of inertia about axis rs passing through the point O through the point O. IRS is equal to I is equal to 1 up to n mi r I square. The perpendicular distance of mass mi from the axis QP is equal to A plus R1 Ri A plus Ri. Hence the moment of inertia about axis QP is equal to IQP is equal to sigma I is equal to 1 to n and mi bracket a plus ri square, which is equal to sigma I is equal to 1 n mi a square plus ri square plus 2a ri whole square, which is equal to I is equal to 1 up to n m I a square plus sigma I is equal to 1 n m I r I square plus I sigma I is equal to 1 n m I a 2a r I. Just normal mathematics it is. Now you can write this as IRS plus sigma I is equal to 1 up to n m I a square plus 2 sigma I is equal to 1 till n m I a r I square, which is equal to, so till here we have solved. Now we have to now at the center of mass, the moment of inertia of all the particles of all the particles about the axis axis passing through the center passing through the center of mass is 0. That is 2 sigma I is equal to 1 and M I A R I is equal to 0. Since A is not equal to 0, therefore sigma M I R I is equal to 0. Therefore, we can write therefore we can write we can also write sigma I is equal to 1 up to n mi is equal to capital M. Capital M is the mass of the total mass of the body. M is equal to total mass of the rigid body. Therefore, we can write IQP is equal to IRS plus MA square. Hence proved. From where I got IQP. So IQP, we have started with IQP. IQP. IRS already written here. And instead of this, so this whole thing mm, becomes 0 and this becomes M A square, capital M A square, and capital M A square we have written here. So this is the proof of this theorem. And this is the end of today's session. Please subscribe, like and share our YouTube channel. Please click on the subscribe button to support us and also click on the bell icon to get automatic notification whenever a new video is uploaded by us. Please like our videos if it is helpful to you. Thank you for your support and giving us your valuable time. Thank you very much.